Here we're asked to determine the sum of the first 20 terms of the series below. And here we have the series minus 5, minus 1, plus 3, plus 7, plus 11, plus dot, 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 or plus 15, plus dot, dot, dot. This is an infinite series, but here it just asks us to determine the sum of the first 20 terms. So we discovered that in the last video, we had that the sum of the first n terms in an arithmetic series is equivalent to n times 2a, where a is the first term, plus n minus 1 times d, all divided by 2. And we also found that this was equivalent to n times a plus t sub n, all divided by 2. Now, here, in order to sum this series, I mean, we could use a similar method to the method that we derived in the, or that we kind of came up with for summing arithmetic series in the last lesson. But why should we do that when we've already derived these this nice formula? So it's important to know where these formulas come from, and then after you know where they come from, feel free to just use the formulas because they're more convenient, or because it's more convenient to do so. So we have that the first term is negative 5. We have that the common difference here is equal to the common difference. Let's see, we're adding 4 to get the next term, so the common difference is 4. And the nth term, or the number of terms in the series, is 20. So n is equal to 20. So now we can just plug in these values. We can say that the sum of the first 20 terms is equal to 20 times 2 times negative 5 plus n minus 1. So we have n minus 1 would be 19. Times d, and d is 4, all divided by 2. We can compute this, so we have negative 10 plus 19 times 4 is going to be 66. 66 times 20 is 1,320. Divided by 2 is 660. So therefore, the sum of the first 20 terms is 660. Okay. We're also given another problem. We're told determine the nth term in the sequence below, and here it's the same sequence, only we're given what the sum is, and we don't know what the nth term is. We don't know how many terms we're summing. So let's write out our formulas again. So S sub n is equal to n times 2a plus n minus 1 times d, all divided by 2. And it's also equal to n times a plus t sub n, all divided by 2. Now, in this problem, let's think about what we're given. Well, we're given a. We're given a is the first term, which is negative 5. We know that the common difference d is equal to 4. And we're not given n. We don't know how many terms are in the series. And we don't know what the nth term is. We don't know what the nth term is. We've got to figure that out. But we do know what S sub n is. We do know that the sum of this series is 1,705, or 1,705. So let's see how we can apply the formulas that we're given. Well, we know that if we use this formula, if we use this form of the formula, we're going to have, let's see, we know a, we know d, and we don't know n. And we would so in this formula we would have one equation and one unknown. If we would have used this formula here, we don't know what n is, and we don't know what t sub n is. So here we would have had one equation and two unknowns. So we would have had to use some, would have had to come up with another equation and solve that equation using elimination or something, because you can't solve for two unknowns using only one equation. We would have had to write it in this form. So in order to solve this problem, we would have taken this equation, we would have rewrote it in this form anyway. So it's better off just to start with this form of the equation. So what we have is we're told that 1705, that's equal to n times 2 times a, so 2 times -5, plus n minus 1 times d. So n minus 1 times d, and d is 4. All divided by 2. Whoops. Okay. So when we go to solve this equation, the first thing that we could try to do is we could try to clear out the fractions. So we can multiply both sides of this equation by 2. And we get that 1705 times 2 is 3410. Oops, 3410. And that's equal to, let's see here, we're going to have n times -10. -10 minus 4 is minus 14. And then we would have plus 4n all over 2. Actually, not all over 2. Okay. Because I already multiplied both sides of the equation by 2 to clear the fractions. So if we actually expand this out, we get 4n squared minus 14n is equal to 3,410. Okay, so let's see here. Well, let's rewrite this equation. If we rewrite this in standard form, we have that 4n squared minus 14n minus 3,410 is equal to 0. Okay, so the next thing we should probably do is we should probably try to see if we can common factor. And here there's a common factor of 2 between all these terms. So we can write this as 2 times 2n squared. Let's see here. 2 times 2n squared minus 7n minus 3,410 divided by 2, which is 1,705. And that's equivalent to 0. So now we're tasked with factoring 2n squared minus 7n minus 1,705. Now, the numbers are really big in this for this last term, but sometimes large numbers may seem difficult to factor. But you know, if the number is divisible by 5, it's really easy to prime factor. So let's go ahead and we'll prime factor this. So 1,705. If we divide it by 5, we get 341. So this is 5 times 341. And let's see here. 341, is it divisible by... it's not divisible by 3, but it's divisible by 11. Okay, so 341 is 5 times, let's see here, this is going to be equal to 5 times 11 times 31. So I guess this only has 3 prime factors. So if we use a guess and check strategy for factoring, there's really not that many factors to guess. So there's only 3 prime factors for 1,705. So let's try some guess and check. So we could write this as 2n. We could have, let's see here, this would be n. And we know that we have these two numbers, these two values have to multiply to negative 1705. So one of them's got to be positive, one of them's got to be negative. Now we could try, let's see here, let's try 55 and 31. So 55, let's try positive 55, and negative 31 here. Well, if we actually expanded this, the middle term would be, the middle term would come from multiplying 55 times n, which is 55n, and then adding to that 2n times 31. So we'd have 55n minus 62n, which is 7n, which is the middle term. So we've factored this correctly. So it really wasn't that bad to factor. It looks challenging and maybe a little bit daunting because this factor is really large, but it's not bad to factor at all. So the solutions to this equation would be n is equal to negative 55 over 2, and n is equal to 31. So we can't have n being equal to negative 55 over 2 because we know that there's a finite number of terms in this series. So the only possibility is that n is equal to 31. So therefore, there are 31 terms in the sum. Or in the series, I guess we could say. And the question didn't ask us to determine how many terms there were. The question asked us to determine the nth term. So remember, for an arithmetic sequence, we have that, or you know, a term in an arithmetic sequence. We have that t sub n is equal to a plus n minus 1 times d. And we know that the first term is, let's see, what was it? It was negative 5. So we have minus 5 plus, now we know that the n is equal to 31. So we have t sub 31 is equal to negative 5 plus 30 times the common difference, which was 4. So it would be negative 5 plus 30 times 4, which is 120 minus 5. 120 minus 5 is 115. So therefore, t sub n is 115. That concludes this lesson, and we'll see you in the next video.